Bright Tuty. Every student matters.
Hello dear students, we are taking up motion chapter. Till now we have studied about the concept of distance and displacement. Fine. So let us read a bit more about speed. We said that speed is the distance travelled by an object per unit time. So the formula for speed becomes speed is equal to distance upon time, right? We represent the speed with small v, distance we represent with small s, and time we represent with small t. So this formula can be represented as v is equal to s upon t. Now students, you need to remember that this small s, we are denoting distance with this small s. Many a times the students, because we are in a habit of writing the initial alphabet, so many a times we tend to make a mistake by using small s for speed, but it is not the case. So s or small s is for distance. For speed, we represent speed with small v and time with small t. Got it? Now the SI or the standard international unit of distance is meters, which is represented by small m, and the standard international unit or the SI unit of time is seconds, which is represented by or denoted by small s. So we can say that the SI unit, that is the standard international unit of speed, is meter per second. These meter per second can also be written as, in their symbolic form, meter per second, or we can write it like meter slash, which denotes per second, or I can also write it as meter second inverse. Now how come this inverse? Because here we assume that the power of second is 1. When it goes up, it becomes minus 1. Normal mathematical fundamental, we must be aware of it. So anyway, I can express the SI unit or the standard international unit of speed. Now mind you, this is the SI unit, right? We are talking about the SI unit. The speed may also be expressed in the bigger units or the smallest units. The bigger unit of speed, the bigger unit of speed is kilometers per hour, because the bigger unit of distance is kilometers, bigger than meters, and time is hours. It may also be expressed in smaller unit. So the smaller unit of speed is expressed as centimeters per second too. We can also express it as centimeters per second. So SI unit is meter per second, bigger unit is kilometer per hour, and the smaller unit is centimeters per second. This is the speed of a particular object. Fine. Now if an object is travelling in a straight line, in a linear motion, and its speed is constant, then we can calculate by how much distance it is covering in how much time. We can calculate with this formula the speed of that particular object. But when the speed varies, which it does, when we say that an object is covering 10 kilometers in 1 hour, the speed becomes 10 kilometer per hour, but that doesn't mean that in every second the speed of the car was 10. It may be more than that, it may be less than that. We are just taking an average of it. In 1 hour, how much distance it has travelled. So this gives us the concept of average speed. We are taking the average speed of the object. Now when I talk about the average speed, the formula remains the same, but the difference is that now average speed is calculated by the formula total distance travelled by the object divided by total time taken by the object for travelling that distance. So average speed is equal to total distance travelled upon total time taken. Fine, right? So this is speed and average speed of a particular object. Got it? Good. Now, if we are talking about the speed of an object, fine, in that case this speed, we can just express the speed in terms of its magnitude or the quantity or the amount only. How much speed, right? How many kilometers in how much time? So this is basically referring to the speed, and since we are expressing in terms of magnitude only, so we say that speed is a scalar quantity. Remember, we did the scalar and the vector quantities. Scalar quantities are those quantities which are expressed in terms of only the magnitude, right? Got it? So speed is a scalar quantity. But if an object is moving, even though it is in a straight line, but if it is taking a turn, if it is changing its direction, then in that case what we do is we represent the magnitude as well as the direction of that particular object, and this gives us another quantity that is known as velocity. Now what exactly is velocity? Velocity, we can say that velocity is the total distance travelled by an object per unit time, that is total time taken, but the important thing is in a particular direction. Now I am adding not only the magnitude, I am also specifying the direction, right? So the difference between speed and velocity, as we can see here, is speed was equal to distance upon time. Velocity is also distance upon time, but in a particular specified direction. We need to mention the direction too, that is, in velocity we take the magnitude as well as direction, and if I am taking velocity, magnitude and direction, both the things in that, so therefore I can say that velocity is a vector quantity. Why? Because vector quantity are those quantities which have magnitude as well as direction. So speed is a scalar quantity, velocity is a vector quantity. Got it? Now if I am saying that velocity is total distance travelled in a particular direction, when we add distance along with direction, in other words, what we can say is this equals to displacement of the body, right? So I can also write that velocity is equal to displacement upon time, because distance in a particular direction is equal to or amounts to displacement. So displacement includes distance as well as the direction. So velocity becomes displacement upon time. Fine. Now when we differentiate between speed and velocity, how we can differentiate is speed is the distance travelled by an object per unit time, whereas velocity is distance travelled by an object per unit time in a given particular direction. Second difference we can relate is speed is a scalar quantity, whereas velocity is a vector quantity. Third very important difference, that is in speed we have taken total distance and total time. None of them can be 0, right? But we have studied that the displacement of an object may be 0. So when I am talking about velocity, I am talking about displacement, and since displacement can be 0, so the velocity of an object may be 0. This is a very important concept you need to remember while differentiating speed and velocity, that speed can never be 0, but the velocity may be 0, right? Got it? Now coming to the velocity, we have said that the average speed is equal to total distance upon total time, right? But when we calculate the average velocity of the object, average velocity, if the body is moving in a straight line covering equal intervals of time with the same speed, and in the direction is also not changing, then in that case the velocity or the average velocity will be the same. But if it is moving with different speeds, different velocities, or in different directions, in that case we calculate the average velocity with the formula average velocity is equal to the initial velocity of the object plus final velocity of the object divided by 2, means I am taking the arithmetic mean of both the velocities, right? Now the average velocity is represented as, this is small v, which is represented as average velocity, written as AV. This is equal to the initial velocity. Initial velocity we denote with small u, plus final velocity we relate with small v divided by 2. So the average velocity is equal to the arithmetic mean of the initial velocity and the final velocity of the particular object. Got it? Now let us take a few questions first of all related to this. Let us take a simple question first. How? I'll take this question. Let us say an object is traveling a distance of 10 kilometers in 2 hours towards north. Calculate its speed and velocity. Now let us see. We know that speed is given by the formula distance travelled by time taken. Now the distance travelled is 10 kilometers, time taken is 2 hours. I will cancel it out. So I will have it 5 kilometers per hour. This is the speed of the object, right? When I talk about the velocity of the object, everything remains the same. Velocity is also equal to distance upon time. Everything remains the same. Distance travelled is same, time taken in the question is same, and the answer is also same. Numeric value wise 15 kilometer per hour, but because we are talking about velocity, we need to specify the direction to, and the direction was given in the question towards north. So now the answer will write, for speed it is just 5 kilometers per hour, but for velocity I will be specifying 5 kilometers per hour towards north. Got it? Fine. So this is the relation and difference between speed and velocity. Fine. Now first of all, while doing these, before doing the questions, numericals based on this, we need to know the conversion of units, right? when we talk about distances, we see that the SI unit is meters represented by small m, the bigger unit is kilometers represented by km, and the smaller unit is centimeters. When I talk about time, the SI unit is second, but I also know that time can be represented in minutes or it can be represented in hours. Now, very important thing, when I am writing the representation of minutes, I will write MIN. I will not write small m. Why? Because small m is a standard representation of meters. This you need to keep in mind, because at times students tend to make this mistake. And hours, it can be represented by small h, or some students make it HR, that is also acceptable, preferably small h. Alright. Now, we need to know the relation between these units. We almost everyone knows it, still to brush up. Now, when I talk about distances, I should know that 1 kilometer is equal to 1000 meters. I can write it as 10 to the power 3 meters also, right. So, 1 kilometers is equal to 1000 meters. If I take other way round, I can also say that in 1 meters there are 1 upon 1000 kilometers, or I can say there are 10 to the power minus 3 kilometers. Have you understood this thing? Please relate it. I am just taking this 1000 below here, opposite, it will come in the denominator. So, if there are 1000 meters in 1 kilometer, then in 1 meter there are 1 upon 1000 kilometers. Similarly, if I take about, this was the first thing. Second thing, I will write about meter and centimeter. I should know 1 meter is equal to 100 centimeters or 10 to the power 2 centimeters. Other way round, 1 centimeter should be equal to 1 upon 100 meters, or should be equal to 10 to the power 2 meters, minus 2 meters. Got it? Fine. So, these two relationships I should know about distances. Now, when it comes to time, I know that 1 hour is equal to 60 minutes if I am converting it in minutes, right, or I can say that 1 minute is equal to 1 upon 60 hours. Another thing, 1 minute is equal to 60 seconds, or other way round, 1 second is equal to 1 upon 60 minutes. Now, if I relate hour and seconds, I should know that 1 hour is equal to 3600 seconds. So, I can also write 1 second is equal to 1 upon 3600 hours, right. So, these are the unit conversions that I need to know. Fine. Another thing we know is whenever we are converting a bigger unit into a smaller unit, we always multiply, and whenever we are converting a smaller unit into a bigger unit, we always divide. This is what you all know already, right, because this is how it is taught in the schools. So, you must be knowing it. Now, let us take a few things based on these conversions. Let us take the first question. Now, in this question, what is given to us is a scooterist covers a distance of 3 kilometers in 5 minutes, right. So, now I will try to relate what exactly is given to me in the question. I am being given distance travelled by this particular scooterist, that is equal to 3 kilometers, and the time in which he has travelled it is equal to 5 minutes, or I can write MIN. Calculate his speed. I have to calculate its speed, the formula for speed I know is distance travelled upon time taken. But the crux of the question is I have to calculate, the first part is in centimeters per second, in smaller unit. Then I need to calculate in meters per second and in kilometers per hour. So I need to basically relate the units. So what I do is I convert this kilometers in meters, right, and in centimeters. How? Let us see. 3 kilometers. Now I know that I can write this as 3 into 1 kilometer, right? 3 kilometer can be written as 3 into 1 kilometer, and 3 into 1 kilometer. Now I will convert kilometers into meters. How come? 1 kilometer is equal to 1000 meters. I know it. So it comes out to be 3000 meters. This is in meters. I have got the distance travelled. Since it is being asked in centimeters also, so what I do is, initially I have got 3000 meters. What I can do is I can write it as 3000 into 1 meter, right? I hope you have understood it. Now I will convert this 1 meter into centimeters. How? I know that 3000 as it is, and rather than writing 1 meter, I can write 1 meter is equal to 100 centimeters. Therefore, it becomes 3 into 10 to the power, I will take 3 units zeros here and 5 here, 3 into 10 to the power 5 centimeters. So as per the question, because I have read the question first, so I know that I will be requiring the distance covered in kilometers, in meters, in centimeters. I have converted all. Similarly, when it comes to time, I require it in second and in hours, but it is given to us in minutes. So what I will do is I will convert it into seconds and hours. Our value given is 5 minute. What I can do is I can write it as 5 into 1 minute, converting minute into seconds first, right? So I can write, rather than writing 1 minute, I can write 5 into 60 seconds, which comes out to be 300 seconds. So this is our time in seconds. Next, I need the time in hours also. So initially the time given is in minutes. I can write 5 into 1 minute. Now 5 into, rather than writing 1 minute, I know that 1 minute, I have just read it above, is equal to 1 upon 60 hours, cancelling it. So I will get 1 upon 12 hours. So now I have got everything in all the units which were asked or required in the question. Now I will calculate how to attempt this particular question. Let us see. First of all, I need it in centimeters per second. So I will take the first case, speed is equal to distance upon time. I know it as it is. The distance I have to take in centimeters. Centimeters, how many centimeters were there? 3 into 10 to the power 5 centimeters, divided by time. How much time? In which unit we require time? In seconds. So how many seconds? 300 seconds. So I will write 300 seconds. I will cancel out this 3 with 3, and these 2 zeros I will cancel out with these, and because here 5 zeros are there, with cancelling 2 zeros I will get 3 zeros. So I will get the power 10 to the power 3. This is centimeters per second, or I can say it is 1000 centimeters per second. This is the speed of the scooterist in centimeters per second, 1000 centimeters per second. Got it? Now second, I require it as in meters per second. Once again I have the same formula with me, that is speed is equal to distance upon time. Let us place the values. Alright, now distance, the question which is asking is meters per second. So distance I will be using in meters. How many meters were there? 3000 meters I have already calculated. So now I will write that my speed is equal to distance, I will write in meters, 300 meters per second. How many seconds were there? 300 seconds. So divided by time is 300 second, cancelling 2 zeros with 2 zeros, 3 1 the and 10 the answer is 10 meters per second. This is the speed in meter per second. Next, I have to calculate the same thing, speed, but in kilometers per hour, bigger units. So now what I will do is, my speed, the formula remains the same, speed is equal to distance upon time, but now it is in kilometer per hour. So how many kilometers were there? 3 kilometers. Distance I can write 3 kilometers, and time I need to take in hours. How much hours I have calculated? 1 upon 12 hours. So I will divide it with 1 upon 12 hours. This 12 will go up. I can write it as 3 kilometers multiply by 12 upon 1 hour, because this 12 goes up. Now just simply multiplying it, I will get 36 kilometers per hour, which can I also write as 36 kilometers per hour. So this is the speed of the scooterist in kilometers per hour. You see how we convert the units, the bigger units into smaller, or vice versa, the smaller units into bigger ones. Got it? So this is the first type of question that may come to us, that we will be given a particular distance covered and a particular time. We have to just calculate the speed with different units. Got it? Now let us take another example. Let us see. Next type of question that may be given to us is, we will be given this question, arrange the following speeds in increasing order. First will be given a car moving at 10 meter per second speed. Second option will be given a bike moving at 200 meters per minute now, and third, a bus moving at a speed of 30 kilometers per hour. Now important thing is, just by looking at this 10, 200 and 30, we cannot arrange these in increasing orders. First of all, we must know what increasing order means. Increasing order means is keeping the lower value first, then the higher value, and then the highest value. That is increasing order, the way they are increasing, right? A normal non-observant student will just see 10, 30 and 200 and he will say, alright, the answer is 10, and then increasing order it is 30 and higher is 200. But that would be absolutely wrong. Why? Because if we want to compare the values, we need to have a particular set of the units which are different here. The first speed of the car is expressed in meter per second. The second is expressed in meter per minute, not second, and the third speed is referred to in kilometers per hour, right? So if we want to compare, we have to bring all these in one single comparable same unit. Now it depends on us whether we want to take it in meter per second, or we want to take it in meter per minute, or we want to take it in kilometer per hour. If I am taking meter per second, then the first value I will keep it as it is. The next two values I will convert in this unit meter per second, so that it is comparable. Similarly, if I take meter per minute as a standard unit to compare, then I'll keep the second the same value, but I'll convert the first value and the third value, the units, into meter per minute to compare it. And if I am taking it in kilometer per hour, then I'll take the third value constant same as it is, and I'll convert the first value and the second value into kilometers per hour. It is the way you want to take it, right? Let us try taking it in SI units, that is meter per second. Now, if I talk about meter per second, the first case of the car, the speed is already given 10 meter per second. I'll keep it as it is. Now, if I am talking about the bike is traveling at a speed of 200 meters per minute, or I can say 200 meters upon 1 minute, right? The unit I want is, I want meter per second. So, in the numerator, the unit is already 200 meters, that is okay, but in denominator, I have got 1 minute. So, I will be converting this minute into seconds. So, what I can write is, instead of writing 1 minute, I can of course write 60 seconds. So, now if I calculate, it comes out to be 20/6 meters per second, or if I calculate it further, it is 3.33 meters per second. This is the value of, or the speed of, the bike. Third case, I am talking about the bus which is moving at a speed of 30 kilometers per hour. Now, 30 kilometers per hour I can express as 30 kilometers divided by 1 hour. I require these units to get converted into meter per second, right? So, what I will do is, I can write it like this: 30 kilometers can be written as 30 into 1 kilometer divided by, as it is, 1 hour. Now, 30 into, rather than writing 1 kilometer, I know that in 1 kilometer there are 1000 meters. So, I have converted this kilometer into meters, divided by, in 1 hour I have studied that there are 3600 seconds. So, I will write 3600 seconds instead of writing 1 hour. Now, simply I will just cut off the values. These zeros are being cut off. I will cut off this 3, 3 1 the 3 and 3 12 the. So, it comes out to be 100 upon 12 meters per second. So, if I will calculate it further, dividing it by this, I will get value of 8 point something. Let us check it. This is 50/6 or 25/3. I will calculate 8.33 meters per second. So, now I have got all the 3 bodies or objects, whether it is the car or the bike or the bus, all the 3 in meter per second, and now I am in a position to compare and relate. When I was talking about the car, the speed of the car is 10 meter per second. If I had calculated about bike, it came out to be 3.33 meter per second, and the bus is traveling at 8.33 meter per second. So, now because the units are same for all these, now it is very simple for me to compare, and because I am asked to arrange them in increasing order, I will write that the speed of bike is less than the speed of bus, which is further less than the speed of car. So, this is the way I will arrange them in their increasing orders of speeds. Got it? Fine. So, this is about the conversion of units. Now, we will take up a few numericals based on speed, velocity, average speed and average velocity. For that, we need to remember a few formulae that we have already done. We know that speed is equal to distance upon time. We know that average speed is equal to total distance travelled upon total time. We have studied that velocity is displacement upon time, or we can say the distance travelled in a particular direction divided by time, and average velocity is equal to initial velocity plus final velocity divided by 2. As and when required, we will write these formulae and we will continue with this numericals. Now, while doing the numericals, students, there is a way of doing it. First of all, you need to see what exactly is given in the question. Secondly, very importantly, we need to relate the units, and wherever required, we need to convert these units. That is the main thing that is required in numericals in physics. You need to convert the units wherever it is required, because wherever possible, convert them. If not asked in question, convert them in their standard international units or SI units. Otherwise, make it uniform, right, so that it is comparable, right. Hope you have understood it. Please try to practice and try to relate. Let us see. All right, the question that we will see over here is, an object travels 16 meters in 4 seconds, right, and then another 16 meters in 2 seconds. What is the average speed of the object? Now, I should know that the average speed of the object is equal to the total distance travelled by the object divided by the total time taken by the object to travel it. Now, when I talk about the distance travelled by this particular object, I see that initially it travelled 16 meters, again it travelled 16 meters, right. So, I will add up these two distances, 16 meters plus 16 meters. Now, divided by total time taken. The first 16 meters it has travelled in 4 seconds, the next 16 meters it has travelled in 2 seconds, right. So, the total time taken is, I will add up once again, 4 seconds plus 2 seconds. So, this comes out to be 16 plus 16 is 32 meters divided by 4 plus 2 is 6 seconds. Cancelling it out, I will get here 16 by 3, or then dividing it, I will get the value 5.33 meters per second. So, the average speed of this particular object comes out to be 5.33 meters per second. Got it? Fine. Let us see the next question. Here the units were simple, easy, normally given. Let us see. Now, in this question, what he is asking is, a train A travelled a distance of 120 kilometers in 3 hours. So, first of all, let us write what exactly is given to us in the question. There is a train A, right. The distance travelled by this train A is given to be 120 kilometers, and the time given for this train A is 3 hours, whereas another train B travelled a distance of 180 kilometers in 4 hours. Now, there is another train B given to us. The distance travelled by this train B is 180 kilometers, and the time taken by this train is 4 hours, right. Which train travelled faster? Now, this is the actual question being asked from us as to which train is travelling faster. Now, if I need to know which train is travelling faster, I need to compare their speeds, right. Fine, the rate at which they are covering the distances, and for calculating speeds, I know the formula that speed is equal to distance upon time. So I'll take this formula and I'll calculate first of all the speed of train A, then I will calculate the speed of train B, and then I'll compare and the answer will be in front of me. Let us see how. Now the distance travelled by train A, I'll calculate both ways. Distance travelled by train A is 120 kilometers, in time is 3 hours. Cancelling it out, I'll get 40 kilometers per hour. This is the speed at which train A is moving. When I calculate the speed of this second train, I know the formula is speed is equal to distance upon time. The distance travelled by this train is 180 kilometers in 4 hours. Now when I'll just strike it off, I'll see it is 90 by 2 or it is 45 kilometers per hour. This is the speed of train B. Now it is quite easy for me to compare which train is travelling faster. So which is travelling faster? Of course train B, which is travelling at a speed of 45 kilometers per hour. In 1 hour it is covering 45 kilometers as compared to the train A, which is running with the speed of 40 kilometers per hour, that is in 1 hour it is covering only 40 kilometers. So train B is our answer. Got it? Understood? Now let us take next question. Okay, in this question what is given to me is, try to relate, a car travels 30 kilometers. So what exactly is given to me is the distance travelled by the car is 30 kilometers. Alright, the distance travelled by the car is given to me to be 30 kilometers at a uniform speed of 40 kilometers per hour. Now the speed of the car is given to me to be 40 kilometers per hour. That is, with this particular speed the car is covering this particular distance, right? And the next 30 kilometers, another distance travelled by the car is given to be 30 kilometers at a uniform speed of 20 kilometers per hour. Now for covering these 30 kilometers, the second leg of its journey, it is travelling at a speed of 20 kilometer per hour. I need to find its average speed. Now to calculate or to find is average speed, I must be knowing the formula of average speed. Now the average speed is calculated by the formula total distance travelled by the object, in which case, in this case it is a car, divided by total time taken. Now the total distance, the first distance, let us distance number 1, distance number 2. The total distance, initially it travelled 30 kilometers and next also it travelled 30 kilometers. So I have got 30 kilometers plus 30 kilometers divided by, I don't know the time. First of all, I need to know that for covering this distance, distance 1, how much time it took, let it be T1, we don't know. And for covering this distance, how much time it is taking, that is, let us say T2, I don't know. How will I be able to know it? Let us see what else is given to us in the question. In the question, we are given speed also. So what is the relevance of giving the speed? We know that speed is equal to distance upon time, right? So speed is given to me 40 kilometers per hour, in this case and 20 kilometers per hour in this case. Distance is given to me 30 kilometers and 30 kilometers respectively. I can get the value of time. So, let us find it, right. How? First of all, I will take this case that the speed given to me here is equal to distance upon time. Speed is given to be 40 kilometers per hour. Distance is 30 kilometers divided by, let the time be T1. Cross multiplying it, I will get T1 will be equal to 30 upon 40. This comes out to be 3/4 hours. This is my T1. Similarly, I will calculate T2 with the same formula, speed is equal to distance upon time. Now, in this case, the speed given to us is 20 kilometers per hour is equal to distance is 30 kilometers divided by time, let it be T2, right. Once again cross multiplying, I will get T2 is equal to 30 by 20, that comes out to be 3/2 hours. Now, the total time when I am counting, it should be equal to T1 plus T2, right. T1 comes out to be 3/4 hours, T2 comes out to be 3/2 hours. So, I will calculate the total time. The total time is equal to T1 plus T2. It comes out to be 3/4 hours plus 3/2 hours. Taking the LCM to be 4, it came out to be 3 plus 3 into 2 is 6 or 9/4 hours. Now, putting this value in this formula of average speed, now I can calculate the average speed is equal to total distance was 30 plus 30, 60 kilometers divided by total time comes out to be 9/4 hours. Now, this 4 will go up, we will have 60 into 4 kilometers divided by 9 hours, cancelling it, 3 3 the 9 and 3 20 the, this comes out to be 20 into 4 is 80/3 kilometers per hour, right. Calculating it further, I will get the value to be 26.66 kilometers per hour. So, this is the average speed of this particular car or object, right. Let us go back to the question once again. In this question, try to relate please. What I have been given was a car travels the first 30 kilometers at a uniform speed of 40 kilometer per hour. I know the distance, I know the speed at which it is moving. So, I will try to calculate by the formula speed is equal to distance upon time. I will try to calculate as to how much time this car is taking for traveling these 30 kilometers at the speed of 40 kilometers per hour. Next, the same, the next 30 kilometers it is traveling at a speed of 20 kilometers per hour. So, I will again calculate how much time this car is taking for traveling these 30 kilometers with this particular speed. Now, I know the total distance 30 kilometers this and 30 kilometers this, and I have calculated the time here and the time taken here. I will just add it up, I will be able to get the total time, and now I am in a position to calculate the average speed, which is equal to total distance travelled by total time taken. Clear? Rest is all calculations. Fine. Units we do not have to change because it is, this is all in kilometers per hour. So, we can keep it as it is because it is uniform. Understood? Fine.